Okay, we're going back to our radicals. And we've done part of this already. So part of this is review, especially this page. Because they're almost the same exact notes. Do you remember what a perfect square is?
Yeah.
What?
Say like 7.
I want more definition, not an example. It's 64 as an example. So describe that. How do you know something is a perfect square? How?
The number's going to be on. As next one has itself.
Okay, it's number something with itself. Yeah.
It can be multiplied by another number by itself. So
Another number by itself.
So like
Okay. So like 64, what's that other number you're talking about? 8. 8 times 8. So let's see, here's like a very general type of way of saying it. And you can use different words, but it's a number whose square root is an integer.
Is an integer like a decimal?
What's an integer? Great question. Is an integer a decimal?
No.
No. What are integers? Integers are not decimals. Integers are numbers like 1, 2, 3, and so on, and also 0, and also -1, -2. Those are integers. Okay? Now if I'm taking a square root, I'm going to leave that alone. Those are integers. So I'm not going to get a decimal. The first 12 perfect squares are, you should know this one, right? What are they? 1,
4,
yeah,
8,
9, yes,
16,
25, 36, 49, 64,
4,
81, 100, 121, 144.
and 144.
wow. Okay, so a lot of you know these. If you don't, that's all you will. So let's at least get those first 12 perfect squares, because we have to be able to kind of say, oh wait, this thing's a perfect square. Easy to take the square root of a perfect square. Okay, let's define what a square root of a number is. Okay, well, now we've done this. What is that? What's the square root of a number? A number divided by itself. Oh, that's close. That's close. A number multiplied by itself. That sounds like perfect square. Kind of. They're related, aren't they? Square root. Square root. They're definitely related. Here's my definition. I said it's the inverse of squaring a number. What does that mean? It's the opposite. So it's kind of like taking a perfect square, but what I'm doing, I'm going the other way. So it's the opposite of squaring a number. It's the number that when taken as a factor twice, gives you back what you started with. I know you know what this is, but we're trying to just get some kind of very general definition. I know you can give me all kinds of examples. What's the square root of, when we go to our perfect square roots, what's the square root of 9? 3. Because that number times itself gives me back to 9. Okay, awesome. You're still writing, that's okay. But while you're still writing and catching up here, what is the square root of 36?
6.
What's the square root of 49?
7.
Square root of 144?
12.
Ruh-roh. Square root of x. How'd you get that?
Because everything
Right,
is
Ryan.
X times.
Oh, why?
because when you have two functions in the class instead of multiplied by each other, it just equals that number.
Yeah, remember it's the inverse of squaring a number. What's x times x? X squared. Right? Isn't it? Well, we have the law of exponents. What's x times x? X, and then I'm adding a 1 and a 1. Right? So it undoes each other. What about, what is this? Oh my goodness.
2x
Square root of 4x to the 4th.
2x squared. 2x.
Cynthia, I bet you know it. How'd you get that? I don't know. I'm just smart. I just know it. You need to guess. That was, he thought of something. How'd you know it was 2x squared? Let's rip that apart. How'd you get the 2?
4.
Square root of 4, right? How about this square root of x to the 4th? Okay. Well, maybe this is what you did inside your head. Maybe you said, gee, what number times itself, or expression, times itself gives me x to the 4th? X squared times x squared, because remember, it's the same base, add the exponents. And get there. Interesting. So I'm just reviewing estimating square roots, because we did this last time too. So I just want to make sure we remember how to do this. Estimate to the nearest whole number the square root of 35. squared, you go 7 up 1 left. See that x squared? There's a square root there. And then you can put in 55, and you can see, round this number to the nearest whole number instead. But it was close, right? That one was a little bit close. How about the square root of 99? 10. I like that you can do that. Like, you can use the calculator, it'll get you by in a test, but to really have that kind of mind that sees it, it's really great. So, nice job there. We do remember how to do that. Okay, this is new. Perfect cubes and cube roots. Oh, now this is an exponent of 3. So we know what a perfect square is. What's a perfect cube? 3 numbers that go into one number. We're on the right track here.
Oh.
Yes?
A number whose cube root is an integer.
Look at this guy. Oh, whoa!
Baby.
He gets like full points there. Wow! And you know, he's a smart guy. He said, let me look at the definition of a square root. And that was a number whose square root is an integer. So to be a perfect cube, your cube root is an integer. Okay? Let's think about the first 10 perfect cubes. Now you rattled off those perfect squares. Perfect cubes, probably not memorized. How do you get those perfect squares? You did 1 squared, 2 squared, 3 squared. So how am I going to get perfect cubes? 1 cubed. What's 1 cubed? 1 times 1 times 1.
1.
2 cubed. Oh, you guys are good. You know this?
Yeah.
4 cubed. Oh, what's 4 cubed?
Should be like near 8.
No.
264.
266. What? No, okay, now let's say, we don't know this one as much. How can you say, gee, I don't know what 4 cubed is. Here's how you cube, quiet. Here's how you cube on the calculator. So it's 4. Where am I going? Watch my little cursor here. I'm going up the operations. See above the divide? See that little like circumflex? You hit that, and I want it to the 3rd power. Press the button, 64. What? 5 cubed.
120.
Right, so I can use the calculator to find the numbers that I don't remember, or I can't do in my head. What is 6 cubed? Right, so you can recreate this list. 7 cubed. Why doesn't say 5? It should be a 125. Wow.
Oh.
Oh, that was silly. Okay, well, I'm sorry. 343.
512.
And then what number is it? 1, 2, 3, 4, 5, 6, 8 cubes, right? 5, 12, 9 cubes, 10 cubes. Finally, an easy one. What's 10 cubes? 1,000, right? 1 times 10 to the 3rd power. So it's great if we can recognize this. I will say, if you can recognize at least, say, the first 5 or 6 of them, just have it. That's going to be, you know, halfway there. But this list you want to kind of keep writing down, keep writing down, keep writing down. We don't have that one quite as strong. What's the cube root of a number, sir?
Inverse of cube.
You guys are really smart, right? Because I saw what it was for square root. I'm just going to replace that word square with cube. And you're right. The inverse of cubing a number. It's the number that when taken as a factor 3 times gives us what we started with. So what is the cube root of 8? Cube root of 8. What number do you multiply 3 times to get to 8? 2. And there's where this list helps, right? Because that's 1 cubed, 2 cubed. These are the cube roots right here, right? What's the cube root of 8? 2. So if you have this list, until it becomes something in your memory, you can get there. What about the calculator, though? What if I want the cube root on a calculator? That's x squared. I want the cube root. Like I said, what's the cube root of 8? What? I know it, but let's say I didn't. I'm pressing the math button. Maybe if you get your calculator, press the math button. Do you see what I need to press next? Look at 4. Cube root of 8. Okay. So if you're not sure, that's how you get there on the calculator. Yeah? Everybody saw that? Okay. What? Not with this calculator. So, but we're going to talk about variables. Because, all right, cube root of 8. We did that one. Cube root of 27. You can use your calculator, or you can look at my list. Oh, here's 27. 1, 2, 3. 1, 2, 3. 3 cubes. Out of autopilot, you're not dividing by 3. Just like square root is not dividing by 2, cube root is not dividing by 3. It's finding that number that 3 times 3 times 3 gives me here. Cube root of 125. 5. Uh-oh. And cube root of x cubed is x. Now, what was the thinking? You guys got there really fast. How'd you know that? How'd you know that, Ryan?
Because there's already cube on the inside.
And yeah, amazing. It's x times x times x. Yeah, it gets me back. What about
2x squared.
okay, I've never in my life had kids just, anybody like, what? How'd you get that?
I got 0.
How'd you get that? What? Alright, let's break it apart. Wow. My head's gonna explode. You look at the number first. For the rest of us who are mere mortals, who have to actually think about this, the cube root of 8. Let's think about this cube root of x squared. Somebody just figure that out. Why is it x squared? How'd you get that? By what? Why? Why would I do that? I love
Just
how
because
that
it's-
works. Why do we do, think of, I have to get to x to the 6, right?
Oh, x squared.
So something, right, something 3 times, right? I need the same number, it has to get me to 6. Now how does this work? When you're multiplying by the same base, what do you do to these exponents? You add them, right? So it's going to be the same number, isn't it? Because that's the same number. So how do what is that? 2. That's the only way I can add up 3 numbers to get 6. 3 the same number. Whoa, that's why it's a divider. 6 divided by 3 will tell you what to put. What? Maybe you followed it, maybe you didn't. So we'll see some more examples. Again, this part, review. You should know this. We talked about this earlier in the year. This thing is a radical. Now you can see maybe why I'm just not calling it square root. I use the same symbol for cube roots. I'll use it for 4th roots, 5th roots, right? I can take a whole bunch of roots. If you have a radical symbol, and it looks like this, this says take the x root of y. That's what I want. So find the number, then you take it as a factor, x number of times, you get this y value. Okay, that's the very general definition. The y, the number inside, you call it a radicand. And so by default, this little x here is a 2. So if I leave out the number here, it means take the square root. And that's the one you're most familiar with. So you could write it like this if you wanted to. You could put a little 2 here. But if you don't, we know you mean square root. But if you're not using square roots, I want to see that little number. All right, simplifying radicals. And again, review. We can simplify fractions. We can simplify expressions. We're going to always simplify radicals just like we always simplify a fraction. Don't we always simplify a fraction?
Yeah.
Yes? Don't we always simplify a fraction? Yes. Just making sure. Okay. It's in simplest form if there are no perfect squares, and I should say, or cubes, or whatever root you're working with, other than 1 in the radicand. There are no fractions in the radicand, and no radicals are in the bottom, right, in the denominator. So let's see. We're going to review those properties that we looked at earlier in the year. If you have the square root of a product, please look up. People have a lot of confusion with this. If you're playing with the calculator, I'm about to take it away. Square root of a product is the same as the square root of the first factor times the square root of the second. Now this goes the other way. So if you see the square root of x times the square root of y, what's that equivalent to? Square root of xy. What about the square root of 2 times the square root of 3? 2 times 3, which would be square root of 6. Okay, so it goes both ways, right? If you're like this, you can break it apart. If you're like this, you can put it together. Depends what you want to do. You know, sometimes it's useful to go this way, sometimes that way. Okay, the quotient property of radicals. I can't keep it as a fraction. You break them apart. And again, it's the same thing backwards. So if you see the square root of x over the square root of it's equivalent to say this. Sometimes it's helpful to go this way, sometimes it's helpful to go that way. You can go either way. Alrighty. Okay, so let's review how to simplify the radicals. Now we have done this already. Let's review how to get a number. Numeric type of what? Yeah, what am I going to do here, Ben?
You're gonna make sure there's you're gonna see what two things you can make this multiply by. Like
So perfect square type of number, or do you want to go to prime factors?
perfect square.
Okay, so if I have a perfect square list, right, remember that? So we look at all our perfect squares, that's probably enough. We say, are any of these a factor of 32? Which one? Because this is 16 times 2, right? That gives you 32. And remember that rule that says you could just break them apart? What's the square root of 16? 4. Yeah, what was the other method? Remember the prime factor method? Some people like that method better. Remember that? Yeah, so how's that one work? How's that one work? Start with 32, right? And then I say, what's the smallest prime number, right? Remember prime numbers? Smallest prime number is 2. Is 2 a factor? Yes. 2 times 16. So that's prime. This is not, right? Because that also has a factor of 2. And so does that. Oh, and so does that. Oh, I'm running out of space here. 2 times 2. Then you look for pairs. Got this one. Oh, I got this one. And one left over. So the ones that are pairs become one number outside the radical, right? This one and this one. And this one stays inside the radical, or radical 2. Yeah? Remember that? Either method's fine. Everybody's listening? I feel like everybody is not listening. We need to be listening. Alrighty. Uh-oh. That's a number. Look at this. Look at that. Well, here's what I would suggest doing. Let's separate out the number and let's separate out the variable. Square root of 9, that's easy. What about the square root of x cubed?
X squared times x.
Yeah, there's 2 ways to think about it. Now remember this method where I look for the biggest perfect square? That's a factor? What's the biggest perfect square? That's a factor. You're going to find that actually the variables are easier to do than the numbers. Because if you have an odd, you should look at me like, what? No way. No way. Okay, let's say I have x to the 5th. What's the biggest perfect square? Well, what's a perfect square when you're talking about variables? I'm going to tell you that these are all perfect squares, and you're going to tell me why. Because they're even, so what? This is a perfect square, so what's its root? 2. Right, x times x is x squared. If x to the 4th is your perfect square, what did you multiply to get there? If x to the 6th is your perfect square, what did you multiply to get there? You see the pattern that's forming here? If you are taking the square root of a variable with an even number, x to the 100th, square root, what is the square root of x to 100? X to the 50, yes. Because x to the 50 times x to the 50, add those exponents, you get back. Yeah? Yeah. Okay, now that's great if you have an even exponent. What if it's odd? That's this one. What's the biggest perfect square? X squared, right? All you have to do is I need one with an even number, so I take the biggest number, even number less than 3, that's 2. Okay, so hang on. X cubed, is that the same as x squared times x?
Yeah.
Can I take the square root of x squared? Just like I took the square root of 16. What's the square root of x squared? X, it comes out. What's left inside? That one. Whoa! Okay. It's the same as this. Okay, let's...
How did the 9 come out?
Okay, because remember if you're multiplying things, it's that times that. So I took the square root of 9 out and the square root of x cubed. It's a perfect square if it comes through. So the numbers work just like they did before. The numbers work exactly like they did before. This one happens to be a perfect square. If it wasn't, I would reduce it like this, right? And then you work on the variables. And we'll do some more examples to see this again. If it's even, it's a perfect square. Divide the exponent by 2, it comes out of the radical. If it's not even, find its biggest perfect square times the other x that's still here. It Now, if you want to do the prime factor method, look at this. This one's even easier. Because what are the factors of x cubed? X times x times x, right? Remember here we look for pairs? Here's a pair. So this one goes outside the radicals. This one doesn't have a match, so it stays inside.
Why does the 9 go out?
Okay, the 9 is a separate. Remember this thing? A times B, right? That's this times this. So that's what I did here. I said square root 9 times square root x cubed. And you kind of solve them separately. What's the square root of 9? What's the square root of x cubed? That's this. X rad x. Okay, so it's just because it's x's, it's a little confusing. But I think it's easier because either method, I'm looking for pairs just like I did here, but the factoring is easy. We're going to do some more. All right, I think we know how to simplify this. What's the biggest perfect square? 4 times 6? You take the square root of 4. Yeah? What's happening here? Well, it's a number and it's an exponent. Let's split them apart and work on them separately. What's the square root of 25? 5. What's the square root of x squared? Okay. So a little bit more of a challenge. This one I just want to review. You know how you can't have you can't have a fraction inside a radical? So we break it apart. Square root of 13 over the square root of 100. You reduce the top, you reduce the bottom. Can I reduce square root of 13? No, there's no other perfect square than 1 as a factor. Square root of 100? 10. Oh, 10. That was nice, perfect square. So now I've got variables. I really am worried about you guys not listening. We do the same thing. You're going to break this apart. And then you say, well, let's see. Can I reduce the square root of 1? No. Yes. What's the square root of 1? 1. Square root y squared. Same process. Yes, sir. We're going to get there, my friend. Good question. Excellent question. Okay. I am doing a little digression here to help a little bit with that question. What is the square root of 6 times the square root of 6? 6. Square root of 36. Which is 6. Look what happened. Does that make sense? The square root of a number times the square root of a number, shouldn't you get the number back? Yeah. So let's look at this, and I'm going to break this one apart. That's the square root of 3 times the square root of x times 4 times the square root of x. When you see something like this, I'm going to put the 4 out in front. You always put the number in front of the radicals. I see that square root of 3. What's the square root of x times the square root of x? X. This one, we'll do the same kind of thing. Square root of 7 times the square root of x times the square root of y squared. Oh, times 3 times the square root of x. So immediately I'm just going to put the 3 up front. Oh, look. Square root of x times square root of x. What's that? X. What's the square root of y squared? Y. Looks like I only got one thing left. So even when they get complicated, pull them apart and work on them a piece at a time. Okay? And we've talked about this. The square root of 4, we always take the positive root, even though minus 2 does work. So we're only working with the positive roots here. Yeah. When you're solving, you're usually solving an equation for a value of x that makes some equation true. When we're simplifying, we're rewriting expressions. What's another way to write this here? That's simplifying. It's just rewriting it. Great question. That's a tremendous question. Yes?
Say you had x to the power 5.
Okay.
When you did a radical.
Okay.
If you split it up, you get x times x times x.
Okay.
Right?
Yes.
So then you have 2 pairs in it.
Uh-huh.
And then you have 1 left. What do you do? There's 2 pairs.
They come out, right? What if you have 2 times 2 times 2 times 2? Doesn't that mean one of the 2s and then another 2 comes out?
Yeah.
So one of the x's comes out, that's this one, and then another x will come out. This one stays inside with x times x.
So it would be x squared.
Yes. Yes. So it works the same way. You guys are great with these. Let me see if I have any more like that. Yeah, I'm gonna come back to that. You really wanna work with that. I like that you did x to the fifth. So one way to do x to the fifth is think about all those 5x's, pairing them up, pulling them out one at a time. Another way to think about it is to say, what's the biggest perfect square that's a factor of x to the fifth? There's always one less. I want the even number, because that's perfect square times x. Are these things equivalent? If you have 4 factors of x and another factor of x, is that x to the fifth? Yeah. It's all. This is the biggest perfect square. What's the square root of x to the 4th? And then I have this left over. So you get the same thing. So I think with variables, this way is perfectly valid. This might be easier. It might be. But I want you to do what you're comfortable with. But I think this might be, maybe start doing this at first, you really get it. But then maybe graduate to that, because I think it is easier. Okay? That's a really good class, I have to say that. Remember rationalizing denominators? Remember this? I cannot have an irrational denominator. Square root of 7 is an irrational number. I can't write it as a fraction. So how do I fix that? Do you remember what we did? What are you doing? Okay, so the bottom I'm going to multiply by radical 7. Why? Because what's the square root of 7 times the square root of 7? 7. But I can't just do that. I have to keep this equivalent. So I'm going to use a form of the number 1, right? Because you multiply by 1, you get the same number back. Anything by same thing over same thing, right? So I get 5 radical 7 over 7. And then you look here and see, can I reduce that? In this case, I can. Right? So let's look at this now. I've got a variable in the denominator. When you get things like this, first see if you can reduce this radical. Can I? 32? No. So what am I going to multiply by? Square root 2x. Top and bottom, right? So let's go across. 4 times square root 2x. What's happening in the bottom? What's the square root of 2x? Times the square root of 2x. 2x. And then you look on the outside. Can I reduce anything? Yes. Look at that. Yeah. We're getting 2 square root 2x over x. Be careful. Can I do that? Can I just cross those out? That's the square root of x. And this is x. That's not the same thing. They only cross out when they're the same. Here it is. So it's very, very similar to what we did before. We got those variables in there. Who's kind of following so far? Anybody have a question? Okay, awesome. Let's do a couple of practice ones here. We're not doing every single one of these because I do want to get to the cube roots. You're not on here? Isn't that special? Okay, yeah, we're going to talk about cube roots. Let me see if we have any on here. I think we do actually. Yeah. Let's look at J. On these examples. Okay. Yeah, see on the so let's talk about this a little bit more. Now cube roots are a little bit different. So let's look at the variables first. The cube root of x to the cube equals what? Cube root now, whoops, of x to the 6th. Because x squared times x squared times x squared, you'll have 6 factors of x. Cube root x to the 33 x to the 11. Yes, because what's x to the 11 times x to the 11 times x to the 11? So if you have a number divisible by 3 as your exponent, it's a perfect cube. Yes, ma'am.
If you don't have it divisible by 3,
that's a whole nother thing. We're going to get there. It's very similar to what we did with the squares. Yes. Yeah, because it doesn't, you can't put in the x in the calculator. Yes.
how did you go from x 6 to x?
This is another question. This is another question. How about, I want the cube root of, I'm doing this. We're doing a lesson first before we come back here. What's the cube root of x to the 27? What? Right, so you're basically just dividing. We can expand this. 4th root of x to the 8. Yes. 16? In the real number system, can I do that? Is there any number times itself that gives me negative? No. What about cube roots?
Yes.
Well, yeah, what do you get? What's negative 2 times negative 2 times negative 2? Negative 2 times negative 2. Positive 4 times negative 2. So if you have an odd number root, you can have negative radicands. If you have an even number root, you cannot. Okay, so that's what's going on here. So we break this apart, just like we did with these square roots. Process same, right? Break them apart. Cube root of negative 27. Now your cube roots may not be so great. So, for now, put on the top of your paper your list of cube roots. And 27, right? 64, 125. So you're going to keep that handy. What's the cube root of 27? 1, 2, 3. But it's negative, right? Cube root of x to the third power. There we go. Right? And again, you can just divide 3 divided by 3. It's going to be 1x. Who's with me? Because, it really is the same process. It's just a little bit confusing here. Let's do this one. Let's pull that apart. That's the cube root of 16 times the cube root of x to the 4th. Let's deal with this number. Is 16 a perfect cube?
Yes.
I'm looking at my list. Is it on there? No. Now, what did we do when it wasn't? Okay, so you have a couple of choices. You can say, what's the biggest perfect cube? That's a factor of 16. Look back up here. Right? That's the cube root of 8 times 2. What's the cube root of 8? 2. And then I have the cube root of 2 left over. The other way is to get prime factorization. 16 is really 2 times 2 times 2 times 2. Isn't it? Okay. Now I'm looking for 3's before I take it out. So now this comes out, and this one stays in. Okay? So you can do that just like, so if you're using that factoring method, if it's a cube root, look for 3 instead of just 2. Yeah? Light bulb! I love it. So if you wanted to do 4th roots, guess what? Do the same thing except circle 4. Okay, so that's fantastic. So that's the numbers. What is the cube root of x to the 4th? This is not divisible by 3. We're going to do the same kind of idea. Now you could do this. X to the 4th is x times x, circle 3. That's what's going to come out, and there'll be 1 left over. You take all the things outside and you put them together. You take all the things inside and you put them together, right? So that's one way to deal with if it's a number that isn't divisible by 3. The other way is to say what's the biggest perfect cube that's a factor of x to the 4th. Yes. X squared is not a perfect cube. Right? I need a perfect cube. Now here's the hint. You look at smaller numbers, go down 1, x to the 3rd. Is that divisible by 3? Yes. Then that's the biggest perfect cube. And so what's the cube root of x to the 3rd? X. And that stays inside. You get the same thing. Though we have to be careful, and I'm going to get a blank piece of paper so it's very messy. So what if you have the cube root of x to the 11? Is this a perfect cube? No. What's the biggest perfect cube that is? Well, go down 10. Does that work? That's not a perfect cube. 9. Go to 9. Okay, now wait a second. I need x to the 11. So it's x to the 9 times what? X squared. So then you say, what's the cube root of x to the 9?
X to the 3rd times x.
And then this stays inside. Yo! Anybody's brain explode yet?
Nope.
Okay? Now, believe it or not, this really is the same exact process. It's just confusing. Now, you could write out 11 x's and circle all the 3's. You're going to get the same thing. There'll be 3 groups that work. You're going to have 2 x's left over. All right, let's go back to this last example here. Oh, what a mess that is. Let me see if I can write that here someplace. So this is the cube root of, 64 x to the 6, y to the 9, over 8. Now, we're going to do the exact same process we did with square roots. I'm gonna break it apart into numerator and denominator. Right, isn't that what we did when they were square roots? Do the same thing. Don't forget the little Frito in this group, that's kind of important, saying not square root. Okay, eventually this will ring a bell in your head. Is this a perfect square on the denominator? I just noticed it. Cube root of 8. So great, I'm just going to take that out because we easy. But let's see, this is the cube root of 64 times the cube root of x to the 6 times the cube root of y to the 9th. And then you have to kind of simplify all that. Oh, wait a second, what's going on here? What's cube root 64? 4. Cube root x to the 6? Cube root y to the 9th. Whole thing over 2. I can reduce this, right? You always look, can I reduce? Yes. 2x squared y cubed. Look at that. This big mess is really 2x squared y to the 3rd power.
Sorry, we lost a marble.
What do y'all think?
That is confusing.
It is. You know what? It is. We're not doing that. It is. But if you really get how to do it with square roots, let's see if I can make up something else. All right. If you have room to write down another example or take out a piece of paper, let's see. I'm doing that maybe a little harder. Trying to think of one. What? You're right here. Do it with me.
No, it's
Oh,
hard.
you're doing Dad. I'm right here. Do it with me. What? Write this down. Cole, write this down. We're doing another example.
Cole just got really.
I'm not doing this with you. I'm going to do it with Dad. Like, hey, I'm right here. Hey. Okay. Everybody write this down somewhere? Cube root of 54, x to the 7, y to the 17. All right. Break them apart into factors. That's the cube root of 54. All right, we're going to break this into 3 smaller problems rather than one big one. Okay, so hang on, this guy's way ahead of me. But okay, so first step, break them apart. So it's like 3 smaller problems. Shush! Okay, cube root of 54. I'm going to use biggest perfect cube. You can also do prime factorization if that works. But again, I want to see my perfect cubes. 8, 27, right, 64. This is usually enough. 54. Are there any perfect cube factors in there? 27. That's the cube root of 27 times 2, right? So cube root of 27 is right here. 1, 2, 3. Count the numbers. 1, 2, 3. It's 3. And I've got the cube root of 2 left inside, right? Okay. I personally think these are easier. What's the cube root of x to the 7? Well, wait a second. So not a perfect cube. So let's see. What is the biggest perfect cube? 8. Go down 1. No, you have to go less. 6. That's divisible by 3 times x, right? This has to equal that. What's the cube root of x to the 6? And then I've got a cube root of x inside. Let's do this guy. Oh, okay, so 17, that doesn't help me. So I need the biggest perfect cube.
15.
Well, let's see, I go down to 16. Still not a perfect cube. 15 is times what? Y. Yes, because it has to be y to the 17. When you're right, that's the equivalent. Are we okay with this part? It's a little bit different. And so what's the cube root of y to the 15th? Y to the 5th power, what's left inside? The cube root of y squared. Okay, now, you're going to collect everything outside. So you get 3x squared y to the 5th. Inside my cube root, don't forget the little 3 here, it's a cube root. I've got a 2. I've got an x. And I've got a y squared. Whoa!
That is so long.
Look at that. This is like, you do this for your parents. They're gonna, like their jaws are gonna go, oh, their heads will explode. Okay, so, doesn't this look like crazy hard? Look at the screen, just step back and look at it. Doesn't this look hard? Just look like calculus. It looks like calculus. It's like, brain surgery. Look at you. It's not that hard, you understand that. Questions, my friends? Well, we could use this in rocket science, they sure do. All right, so here's my advice. So I want you to practice your square roots first, because we still have to know how to work with the exponents and square roots, and work with the cube roots as well. Do the best you can with them. Go back, watch the video if you need to. Get help with it, but I think you guys got this. Any last questions? Yes, sir. Okay. Which one? Where is it? What number does it say? Oh, where is it?
At the top of the page.
What page are we looking at?
13 over 100.
Okay, which one?
What if
1 over y?
Yeah, what if y had a 5?
Okay, yes?
What if y had an
Excellent question. How do you do this? Yep. So it's still going to be 1 over this. I would simplify this first. Let's simplify square root of y cubed. Now we're square root. So what's the biggest perfect square?
y squared
Times y. Take this one out, you get a y. Okay? So y, that is that, right? So I'm going to rewrite that as 1 over y radical y. Okay, now, what should I multiply by, Noah? Radical y over radical y. So I get 1 times radical y. Great, I'm so glad you asked this. Now here's a y, it's still sitting here, right? What's the square root of y times the square root of y? Y. Well, what's that? What's y times y? Boom. Awesome. Fabulous question. Fabulous question. Any other good questions like that? That was fantastic. You guys have impressed me greatly today.